So in the last class, we have started from here, and after that we have discussed about the charge. What is charge? And there are two types of charges, positive and negative. And SI unit of charge is coulomb, and this thing we know very well. And after that, I have discussed the Coulomb's law. Okay.
Yes.
Coulomb's law. What is Coulomb's law? Coulomb's law is basically telling the force between the charging. Nothing. It is just telling the force between the charges. Force is given by this formula K Q1 Q2 by R square. Okay. K
Yes.
Q1 Q2 by R square. And if you are placing the charges in a medium, then you will use epsilon naught M for
Yes.
the K. And if you are placing the charges in air, then you will
Epsilon
use
naught.
epsilon naught. And in most of the cases, the charges will be in air in your syllabus. Then we will use the formula 1 upon 4 pi epsilon naught. Okay. And I think that this formula will be used always. Because I will suggest you to remember this formula. Okay. This formula is very F is equal to K Q1 Q2 by R square, and K is equal to 1 upon 4 pi. And if you do not learn this formula, then it's okay. Okay. This is not necessary. Where is that? This one. This formula is not necessary. Okay. You should remember this only. And what is the value of K here? 9 into 10 to the
9
power
to
9?
10. Yes.
9. Okay. So this is very important formula. Very important. So now we have done till here now. This question we have completed, and we have the answer. F dash is equal to 16F, and now I am moving forward. So now our next topic is dielectric constant and relative permittivity. And this you should remember. And forget all the thing. Not forget all the thing, but this is most important.
Yes.
So now let's see. Dielectric constant. Dielectric constant. You can represent dielectric constant with K or epsilon naught R. And this dielectric constant is also known as relative permittivity. Now, how I will calculate this? We have two charges. Q1 and Q2. And distance between these two charges is R. Okay. And these charges are placed in air. So the force of interaction, maybe it will be repulsion or it will be attraction, no matter. Now I am talking about only force. So force will be F. What is F? F is equal to K
KQ1
Q1
Q2 by
Q2 by
R square.
R square, and value of K will be 1 upon 4 pi epsilon naught Q1 and Q2 by R square. So it means that I can write 1 upon 4 pi epsilon naught Q1 Q2 by R square. This is our equation 1. Now these are two same charges, and now what I am doing, holding these two charges, and no. First I have to copy. Please have patience. Okay. Here. Now it's fine. Now what I have done, I have taken this system and placed in any other medium. In any other medium means other than air or vacuum. Okay.
Yes.
Other than air or the spelling of vacuum is correct or not?
Yes, sir.
The spelling of vacuum is correct or not?
Yes,
I
sir.
think it is correct. Okay, that's not a problem. So now, if I am saying I want to calculate the force in between these two charges, what is the value? K Q1 Q2 by R square. But this time K equal to 1 upon 4 pi epsilon naught M. Why? Because now these two charges are placed
Another medium.
in another medium, so we will use this epsilon M instead of epsilon naught.
Epsilon naught.
So I can write the value of force as 1 upon 4 pi epsilon naught M Q1 Q2 divided by R square. This is my question second. This is my question second. So now if I am dividing equation 1 by equation 2, okay, we can do that now.
Yes.
Dividing equation 1 by 2. So what will happen? Now I am taking the force F naught is the force in air and Fm is the force in medium. So what would happen? We are dividing equation 1 by 2 means we have to write F naught by Fm, and let's see, when you divide this term with this term, these things are same now. Q1 Q2 by R square, Q1
Yes.
Q2 by R square, these terms will get cancelled out, and 1 upon 4 pi will also cancel out from here.
Yes.
Okay, and what will
Epsilon
happen?
naught
Okay,
by epsilon M.
this epsilon naught will be in denominator and this
Epsilon M.
epsilon naught M in numerator.
Numerator.
Okay, Okay, fine. Sorry. And this is mm, equal to K, dielectric constant. Finished. So what is dielectric constant? Dielectric constant is this thing. I can define dielectric constant like ratio of force in air to the ratio of force in medium, or I can define dielectric constant as absolute permittivity of medium divided by absolute permittivity of
Air.
air. This is dielectric constant, and you can also say K as relative. What was that? Relative permittivity. That's not a problem. You should remember there is a K, that is dielectric constant. So this is our relation, and this is very, very important relation. Very, very important relation. Because we will be given, examiner will give the value of K. So let's see. And now I want to tell you one thing. If I am taking like this is like this, F naught divided by Fm equal to K na, I can write. Okay, fine. So this K is greater than 1 always. This K is always greater than 1. So can you tell me which one is greater? F naught will be greater or Fm will be greater? If this K is greater than 1.
Yes, and K is equal to F naught by Fm.
No, my question is, look at this equation here. Okay, look here. And now I am saying this K is greater than 1. If this K is greater than 1, so F naught will be greater or Fm will be greater?
F naught?
F naught will be greater. Why? Because when we will write this like F naught equal to K into Fm. So means we are multiplying something which is greater than 1.
Yes.
Okay, means greater than 1. So it means that this will become more. For example, you can say like uh, F naught and K is greater than 1. Take any number which is greater than 1. I am taking 2 of Fm. So what does this mean? This means that F naught is 2 times of Fm.
Yes.
So we can say F naught will always be greater. Okay. So we can also say the force of interaction is always greater in air. Okay. Is always greater in air. Fine.
Yes.
Suppose if I am placing two charges in uh, in some gas, in some medium, or same system of charges I am placing in air. So in which system the force of interaction will be greater?
In air.
In air. Very good. And if I want to calculate the force in medium, then what should I do? First, from here you can see now. we have this f naught by fm is equal to k. So can I write this as fm by, okay, no problem. We will do it different way. Now I am multiplying. I can write this like k into fm. And from here, if I want to calculate fm, force in medium, so what I need? I need force in air. Simply I will calculate force in air and I will divide the dielectric constant of that medium. We will got the answer. We will not require this force. So this thing is also, you should remember. Fine? Are you getting my points or not?
Yes, sir.
Actually, na, this k is the dielectric constant of medium. There is any medium, there will be any medium and whose dielectric constant will be k. Now let's see. Value of dielectric constant. Values of k. K is dielectric constant. For air, if we have air, then k equal to 1. No problem. And for conductor or conducting medium, do you know what is conductor?
Yes, which does not allow the flow of charges.
What?
Conductors as in metals and all, which does not allow the flow of charges through it.
Means in conductors can current flow or not?
Yeah, current can flow. Like example, metals.
Very good, very good. In metals, there are free electrons and they are conductors. So,
Yeah, and charge carriers are like
yeah,
electrons.
charge carriers are electrons. And due to those electrons, the current is generated. Okay.
Yes.
And for water, k equal to 80. Now, mm, this is the question. two charges are placed in a conductor or in a conducting medium. So we have to calculate the value of force. We have to calculate the value of force. Now, how you will think this? Let's see. Here will be, you can write two charges, okay?
Yes. That's Q1 and Q2.
You can assume Q1 and Q2. Like this is Q1 and this is Q2. And they are placed in conduct, like you can see like this. These are two charges, and in between the charges there is a conducting medium. There is no air. There is a medium which is a conducting medium. Okay, so you can imagine like that. So what we have the formula, we have, if I want to calculate the force in any medium, we have this formula, force in air of divided by K.
Yes.
Medium, and this medium will have some K. Conducting medium will have some K now.
Yes.
So I want to calculate the force in medium, F naught by K. What is the medium here? F, conducting medium. Fm is equal to F conducting now.
Yes.
And don't calculate F naught. No requirement.
Okay.
And now what is the value of K? They are placed in conducting medium. For conducting medium, K is infinite. K is infinite now. And 1 by infinite means? Hello? What is 1 by infinite?
Value.
What is the value of this? This is infinity,
Yeah,
infinite.
that does not have a value.
Huh? This will be 0.
Yeah, because it does not have a value.
So this whole term will become 0 now.
Yeah, so F conducting is 0.
Like you can see, you can write this F naught into 1 by infinite now. And
It's, and
1 by infinite have value 0. And you can multiply
0
any number,
multiply
whether it is
0 is 0.
whether it is in crores, whether it is in billion, whatever, it will become 0.
Yes. Okay.
So you can say that the force in the conducting medium, force between the charges in conductor is 0. Okay.
Yes.
Do you want to note it down?
Yes, sir.
Okay. From here. And please ask me if you have any doubt.
Yes, sir.
Next, 7:30, 7:39.
So you can go down. I wrote this already.
Should I scroll down?
Yes, sir.
Okay. Now fine.
Yes, sir.
Okay.
Sir?
Okay.
Yes, I got this. Please scroll down.
Okay, okay. Give me a minute. Uh, completed till here. Uh, completed this now. Hello. You have
Oh,
completed
yes,
this.
sir. Yeah, I was speaking, but it was muted. Yes.
Now it's okay, na?
Yes, sir.
Okay. Please note it down. From where you are?
Sam from Qatar.
From Qatar. Okay. Should I scroll down?
Yes, sir.
Please note it down and take your time. No problem.
Sir, I wrote. Yes, sir.
Done?
Yes.
Completed till here?
Yes, sir.
Are you sure?
Yes, sir.
Okay, fine. Let's move. And have you understood this now?
Yes, dielectric constant.
Dielectric constant. This is the derivation part, and finally we came here. This is the thing. This is
Yes.
the thing.
So this is
And
part of the first chapter, electric charges, right?
yeah. Actually, we are continuing. I am continuing with my previous lecture that you have
Coulomb's law.
studied, na, with Coulomb's law. Like here, na, we have started. You can see. This is our first chapter.
Yes.
This is first chapter, no? And first chapter is started from here, from charge, and it is going, still going, and still going, and going, and now we are here. This is the first chapter.
Yes.
Okay,
Yes, sir.
you can write this question with me
Okay, fine.
as I am writing. So it will save our time. Actually, there is one thing that I want to tell you. There is uh, a difference in studying the theory and numerical. They are two different things.
Yes, sir. Like you derive the equation and then the formula you use it in numericals, but like it's not exactly the same way. Like you have to
Yeah.
it's twisted.
Actually, what is thing is that in numericals we use formulas, and there is a term
Analytical
analytical
theory
thinking.
thinking.
Actually, in numerical part, we should have this approach, analytical. We should think analytically. Means, what is the meaning of analytical thinking? Means breaking down the problem, breaking down the problem in the part. So I see most of the students are good in theory, maybe good in theory, but they are not that good in numerical. Why? Because you should you should change your thinking when you are solving the numerical. Okay,
Yes.
so I am just suggesting you, when you are solving a numerical, there should be a different approach, and when you are studying the theory, there should be a different approach. Okay, actually, in physics, what happened? Physics is a study of natural phenomena. These all are natural phenomena. Okay, we you haven't seen charges. We have not seen the charges. I have not seen what charges, but we are studying the charges so as to develop our thinking. We are studying the physics. We are studying the nature. Okay, so this is the thing in physics. That's why I most of the students don't like physics, because their thinking is different.
Yes.
I cannot see force. You also cannot see force, but they should feel that. They should try to feel that at least. Okay, no problem. So now we have to solve this numerical. First thing, to solve the numerical, read the numerical carefully. Two charges, Q1 and Q2, when placed at a separation r in air. Okay, so what why I'm doing? Two charges at a separation r, Q1 and Q2 are the two charges, separation in air, and repel each other with a force F.
Yes.
Means,
When repel means they're
हाँ,
same charges because they repel each other.
oh, sorry. There,
At a separation R in air repel. So this is air medium. Repel each other. Force F. And F is like K, Q1, Q2.
very good, very good. And F is given in the question. And what is F? We already know.
Yes.
F is equal to K
Q1, Q2 by R square.
K1 Q2 K1 K Q1 Q2 by R square. And I can write here 1 upon 4 pi epsilon
Epsilon.
naught.
Q1, Q2 by R square.
This is the first part of the problem. After, in air, repel each other with a force. At what separation both the charges must be placed in a medium of dielectric constant 3. This is dielectric constant 3. Okay. So now what I am doing, the examiner or the question, in a question, it is asked that at what separation. Now earlier this thing in air. Now we have to place this thing in a medium, and we have K for that medium. I have told you this, actually these two K's are different. Okay, this is dielectric constant. Okay,
Yes, sir.
please don't get confused in this K. Okay. Actually, I am removing this K from here. I can write the formula like this also. Now it's fine. K equal to 3. Dielectric constant is 3. This is given. Now what we will do, we don't know where we have to put the charges, but we will apply some mathematics like these two charges. Suppose this is charge Q1 and this is charge Q2. And I don't know what will be the separation in this medium, so I suppose the separation should be X. This is not N, this is X. Okay, I am supposing that in a medium when
Charges are separated by distance X.
So now let's see. I have told you that if I want to suppose this is FO. If I want to calculate the force in medium, what is the value? 1 upon 4 pi epsilon naught m into Q1 Q2 by
Square.
X square. This will be X square.
Yeah, because it's X. Yeah. So we.
This is X square.
So we let the distance be X for the question.
Now what I am going to do, I am dividing this equation by this. Same thing I am doing. This will be F naught. No. Please do one thing. It will be easier. This will be easier. Actually, we have that formula na. F naught is equal to K times of Fm.
Yes.
This will be okay. So, but there will be a problem. So we have this formula. Actually, we will use this formula also. This Em by E naught by K. Em by E naught is also K. Okay.
Yes.
So we have Em by E naught is equal to K. So in this way, I can write Em by E naught. What is the value of K? Is 3. So I can write Em as 3 into this epsilon naught.
Yes.
And now what I will do, I will put this value of Em here. So what we will get? So Fm will become 1 upon 4 pi. Now please tell me, instead of this, what should I write here? 3
epsilon naught.
Okay. And the whole story will be like this: Q1 and Q2, and this is X square.
Yes. The value of K was 3. That's why it came this way.
Yeah.
And
so,
we put the formula epsilon m by epsilon naught.
Epsilon m by epsilon naught, and I have written there.
And dielectric constant is equal to K.
Yeah. So this was the equation number 2.
Yes.
And this is the equation number 3. So now, now you can write there are many ways to solve a question, but I always try to solve a question with a simplest method. So I can write it as force in air equal to K times of force in medium.
Yes. Okay. KFM.
KFM. So what is the value of force in air? Force in air is this. Force in air is this and force in medium is this. So what I am going to do now, what is F naught? I am putting F naught. F naught is 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. Okay. And what is the value of K? K is 3.
Yes.
And one thing more, we should know that this F is given here. Okay. So F is given means value of F naught is F.
Yes.
Okay. Value of F naught is F. And what is the value of K is 3. And Fm is 1 upon
4 pi
4 pi epsilon naught. Epsilon naught. And this is 3. And this will be Q1 Q2 by R square. Okay.
Yes.
Not R square, this will be X square. So now actually I have done some mistake, I think. Here I have written this 3 epsilon naught, and after that actually no, we are missing one thing in this question. Actually we are missing one thing in question, that's why this thing is not happening correctly. At what separation both the charges, actually the question is incomplete. Someone give me the incomplete question. At what separation both the charges must be placed in a medium of dielectric constants 3 so that the force remains same. See, the question was wrong. The force remain same.
Same.
So force remains same means now, and sorry for that,
No problem, sir.
we have done all the things correctly.
Only the last one.
But actually the question was someone given me the wrong question. So here I have calculated this F, and here I have calculated this Fm. So means this force in a medium will also be F now.
Yes.
Now what we will do, I will equate the equation number. This Fm will equal to F. Force in medium will be same. Means I will equate equation number 3 and equation number 1.
1.
1 equal to 2. What is 1? 1 is this. This is equation 1. We have, and I am equating this with this equation. Means F is F same, means I can equate this is equal to this. Are you getting my point or not?
Yes, sir.
1 upon 4 pi 3 epsilon naught q1 q2 by x square, and we have to find the x. Okay, no need of this now. So now let's see. This q1 q2 gone. This 4 5 gone.
Yes.
And this epsilon naught gone. Now what we have here, we have 1 upon r square, and here we have 1 upon 3 x square. So I can write as r square equal to 3x square. Can I write this? Okay.
Yes,
So
sir.
from here I can write x square equal to r square by 3. And if I will calculate x, then x comes out to be r upon root 3. This is our answer. Means we have to place these two charges at a distance of r by root 3. R by root 3. So please note this down, this question.
Yes, sir.
Firstly, we have placed the charges in air. We have the force F. Okay, we have the force F. And after that, what we have done, we have placed again those charges in another medium. And the question says, when you are placing those charges in another medium, the force will remain same. So we have calculated the value of force. We have calculated the value of force, and this force will equal to F, same as earlier. And what we have done, we have equated these two forces like this, and we got the answer. Simple thing.
Yes, sir.
But at that time, the question was not correct. Have you noted, or you are writing?
I noted the question.
You have noted the question. Now please write the answer. Please note this point, that in both the medium, force is same, given in question. I'm writing here. Given in question that in both the medium, force is F. Scroll down.
Yes, sir.
We have 5 more minutes.
Yes, sir.
And I am having a class at 7:30.
That is 5 o'clock of here. Yeah.
7:30 means in India is,
Yeah, in Indian time, yes. Indian Standard Time.
yeah.
So you can scroll.
Okay. So have you understood this question or not? This is a little bit, I think, complicated
Tricky.
question for you.
Yes,
Please,
sir, I understood.
I understood, but you understood, but you should try to think this
You
thing
said
at
to,
your,
yeah, you said to break the questions and like check
yeah,
that
yeah,
if you take the
yeah,
information out and then
yeah,
do it.
yeah, yeah. You should try to solve this question at your when you are free. Means okay.
Yes,
After
sir.
after this class, you should try at least how these things
Okay.
happen.
Oh, okay.
Noted, na?
Yes, sir.
So, what I have done here, but there is a twist here. This was the twist. We should know this. Okay. So, you are in 12th class now.
Yes, sir.
Okay. And have you already read this done this chapter?
This one in class, yes.
Fine. So, in today's class, let's recap. I have started from the dielectric constant. Dielectric constant is simply K or ER. You can say K, or it is also known as relative permittivity. And after that, what I have derived how dielectric constant comes when I placed two charges in air and I have calculated the force. And after that, I placed two charges in any other medium whose dielectric constant is K. Okay,
Yes.
and I divide both the equations and I got this formula, and I have marked start this formula because this is important. Okay, and after that we have done this. If I want to calculate the force in some medium, then what will I do? I will simply calculate the force in air, and after that divide it with the dielectric constant K of that medium. And there are some values of dielectric constant, like for air is 1 and for water is like this. And after that we have completed a question. There will be no charge in the conductors when we place the charge in the conductor, as these na. And after that, this question
Yes.
is little bit